So study of the magnetic field is complete. So the electrical resistance, and this topic electrical resistance is a part of the physics, and this belongs to the unit 11. So here, what is electrical resistance? So basically electrical resistance is the property of a conductor which oppose the flow of a charge. What is property of conductor or wire which oppose the flow of charge? Oppose the flow of charge. So basically in previous slide we explained electrical current and its property. So here basically resistance depend upon the arrangement of the atoms and length of the conductor and also area of the conductor and additional what is temperature. So this depends upon first what length of wire and second what is area of cross section. So these both factors are depend upon the shape of the wire. For example, this is a wire and this is the area of cross section A and this is the length of conductor L. So basically on the basis of the shape only depend upon length and area, but resistance also depend upon the what is temperature. So these are the important factors of the resistance. So here what is length? If L increase, resistance increase, because L directly proportional to L, and second are inversely proportional 1 by A. So here what happen, if we increase the area, then resistance decrease. So R decrease. And third, if we increase the temperature, then what happen? Resistance increase. So these already explained in previous lecture. These are the important factors in which resistance of the conductor or a wire depends. So, and one more important thing here, SI standard unit of the resistance is ohm. And this is represented by the symbol Greek letter ohm. So this is the symbol which represented by ohm, and what is formula of a resistance? V is equal to Ri. So here R is equal to V by I. So what is R here resistance and what is V here voltage and I is current. So here resistance defined in term of voltage and current, and unit of the voltage, SI unit of voltage, what is volt. So R is equal to volt, and unit of a current is what is ampere. So we can write this volt per ampere, and this volt per ampere, this volt per ampere known as ohm. So these are important concepts, sometime asked in boards. So what is SI unit of a resistance? Ohm. So next we study about the combination of a resistance in series and parallel. So what is? So combination means many resistors are connected in a circuit. So resistors are connected in a circuit in two types. First type may be in parallel and second type in series. So how to connect it? Two types. So first, what is parallel combination? And second, what is series combination? So how resistors are connected in a parallel? For example, we take three resistors. So we assign name R1, R2 and R3. For example, these are resistors. So this name R1, this name R2 and this name R3. So basically these resistors are fixed resistors whose resistance does not change, and another type of a resistor also count, that is known as variable resistor. So variable resistor, that resistor whose resistance vary. So here we take fixed resistor. What is fixed resistor? So here we connect these resistors in two ways. First series combination and second parallel combination. So how to connect it in a series combination? For example, these R1 resistance, these and A, these and B. And second resistor whose and this and C and this and D. And third resistor this and E and this and F. So how to connect it in a series? In series combination, connect and B with C and connect D and with E. So tail of the one resistor connected to the head of the other resistor. So here what type of combination form? So this type of combination form. So this resistor, what is R1, and this is what is R2, this is R3. So this and AB, and this is CD, and this is EF. So this combination known as series combination. So here we connect voltage, and we also connect here ammeter and voltmeter. So ammeter and voltmeter connected in next slide. So this is series combination. And second, what is parallel combination? So in parallel combination, connect. So these are, and for example, A, C, E are connected each other, and B, D, F are connected each other. So here what combination form? For example, this and A and this and B, this and C, this and D, and this and E, and this F. So connected each other, and this and connect with a voltage. So this is R1, R2 and R3. So this combination known as parallel combination and this combination known as series combination. So here in parallel combination voltage is same. So we can write here in parallel voltage is same but value of current different. So value of a current different means when supply I here, so these electrical current divide into three paths. For example, I1, I2 and I3. So in parallel combination, value of a electrical current is different, but here voltage is same. So what is voltage here? V. For example, voltage is equal to 10 volt. So here say each resistor 10 volt, but in combination series voltage is different and current is same. For example, this voltage and this supply electrical current I. So what is value of here? I. So here path is same. So here only single path. So electrical current remains same. So here current also I. Here also I. So here electrical current across R1, R2, R3 is same because here single path. So here single path electric current same. But here we see here there are different path, three path. So electrical current divided into the three path. But here voltage, this voltage divided into three parts. For example, here this is V1, this is V2 and this is V3. So V is equal to V1 plus V2 plus V3. So these are important points because these knowledge of a voltage and current are used in numericals. So these are the important circuit of a resistance, only two types, parallel combination and series combination. So next we derive the formula of a resistance in series. So formula of resistance in series. So first of all we take three resistors which are connected in series. So these are resistors So here what is these resistors, for example, R1, R2, R3. So this is what is R1, R2 and R3 connected in parallel. So here we make a circuit diagram of a parallel. So we write here this is parallel combination. So here formula of a resistance in parallel combination. So R1, R2, R3 connected each parallel because both ends are connected each other. So this combination is a parallel combination. And here we connected voltmeter. So what is the function of a voltmeter? So function of a basically voltmeter to measure the voltage across the device. So here what is device? Resistance. And here what is this? This is ammeter. So what is the function of a ammeter? Ammeter to measure the value of a electrical current. So this is what is V. So V is voltmeter. To measure voltage. And second, what is this? This is ammeter. So ammeter measure current, and this is what is voltage, and this is switch. So basically this switch is open circuit. When we put here dot, so that this is closed circuit. So what happen when we apply voltage, then electrical current flow in the circuit, and direction of electric current taken positive to negative. So here this is positive and this is negative. So what is the direction of a here current? This. So this is the value of a I. So here I divided into three parts. So basically I divided into three parts. This is I1, this is I2, and this is I3. So this is the circuit diagram of a parallel combination. So we can write here these terms in the form of some definitions, like, so we can write R1, R2 and R3 are three resistors are connected in parallel with voltage V. Okay. So here what is important? R1, R2, R3 are three resistors are connected in parallel with a voltage V. Okay. Next, what is I1, I2, I3? So we can write here I1, I2 and I3 are the current flowing across the resistor R1, R2 and R3 respectively. So here what is I1, I2 and I3 are the current flowing across the resistor R1, R2 and R3. And here we already write here what is V. Here voltmeter the voltage and it is a ammeter measure the electrical current. So here one more important things, voltmeter always connected in parallel. What is voltmeter always connected in parallel and ammeter connected in series. And here important what is positive terminals of the voltmeter connected with a positive and negative terminals of the voltmeter connected with the positive terminals of the voltmeter, and voltmeter negative terminals connected with the battery negative terminals and positive connected with the negative. If you do wrong connection, what happens? These devices are damaged. So ammeter and voltmeter are damaged if you connect them wrong polarity. So this is the circuit of a parallel combination. So here we derive the formula of a resistance in parallel. So here we know that electrical current is different because current divided into three parts. So we can write here what is here total current. So total current here I. So here I is equal to I1 plus I2 plus I3. And we know according to Ohm's law, we know V is equal to IR. So this is according to Ohm's law. So this Ohm's law already explained in previous lecture. What is Ohm's law? Current produced in a wire directly proportional to the applied voltage and kept physical condition constant. And we derive the formula V is equal to IR. So here we find out the value of a I. So what is I here? I is equal to V by R. So I is equal to V by R. So voltage here, what is same? So voltage is same across the resistor. So what is I1? So I1 is equal to V by R1. I2 is equal to V by R2. And I3 is equal to V by R3. So we can write these 1, 2nd, and equation 3rd and equation 4. So put value of a I1, I2, I3 and I in equation A. So this equation like A. So we get the value. So put value here. What is the value of a I? V by R. So put here. So put here this. So what is value? V by R. Put here I1 V by R1 and put value of here I2. So what is V by R2 plus V by R3? Value of a I3. So here we take common V. So we take here common V by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3 and take here common V. So V to V cancel. So we get here So we get here 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is the formula of a equivalent resistance in parallel combination. So we write here RP. So this is a combination of a parallel. So total resistance is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Here only we take example of a 3 resistor. If we connected many resistor, n number of resistor, so we write here this plus 1 by R1, Rn. So for example, here connected to 4 resistors, so we can write 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4. So sometimes simple numerical comes, for example, this value 10 ohm, for example, this value 4 ohm, this value also 4 ohm and 4 ohm. So what is the equivalent resistance? So put this value in a formula. So what is value of a R1? R1 is equal to R2 is equal to R3 is equal to R4. So this is equal to 4 ohm. So put here value. So 1 by RP is equal to 1 by 4 plus 1 by 4. So taken here LCM. So if you take LCM here, so 4 LCM, this is 4 by 4 and if 4 by 4, this is equal to 1 ohm. So 1 by Rp is equal to 1 ohm and this implies Rp is equal to 1 ohm. So what is the equivalent resistance of this circuit? 1 ohm. So these complete circuit converted into single resistance circuit like this. This is voltmeter and this is ammeter. So what is 1 ohm? So these both circuits are equal because this resistance 1 ohm equivalent resistance of a R1, R2, R3. So many types of circuit we can here solve. So like this is another circuit and here voltage connected. This is equal to 10 ohm, 10 ohm, 10 ohm and 10. So find out the total resistance of this circuit. So what is the total resistance of this circuit? Use formula. What is formula? 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4. So this is equal to 10. So put here 1 by 10 plus 1 by 10. So this is equal to 10 by 4. So this is equal to 2 by 5. So 1 by Rp is equal to 2 by 5 and Rp is equal to 5 by 2. So this is the value of a equivalent resistance. So we converted this circuit into a single resistance like this. Positive, negative, and this resistance 5 by 2 ohm. So both circuits are equal. So this topic finish here. So in next topic we study combination in series, and we derive the formula of a resistance in series. So if you have any query, then put your suggestion in comment box. Thank you very much. ठीक है सर.